Alright, so for example 6, I'm actually going to go ahead and skip this one. It's a little bit complicated, so I'll leave this one for class. So we'll move on to example 7. Alright. For example 7, you'll notice that you have two separate trig functions. One is sine, one is cosine. This was what I was talking about in one of the steps earlier, that we want to make sure we have all the same trig function. So since you already have two sines and you have this cosine squared, we want to change that to a sine by using one of the identities. We'll change that into 1 minus sine squared. And so now you'll notice you have all the exact same identity, or all the exact same trig functions. So I'm going to go ahead and clean this up a little bit, collect our like terms. So what I did is I added negative sine squared and negative sine squared. That'll become negative 2 sine squared. It'll become a plus sine theta and then plus 1. But at the same time, I went ahead and divided everything by negative 1. So that negative 2 sine squared I talked about becomes positive 2 sine squared. That positive sine theta became negative sine theta, and that positive 1 became negative 1. So if you divide everything by negative 1, you would do the same thing on the right side with 0. 0 divided by negative 1 is still 0. So now when I go to factor this, it's very easy to do. And so these would be the two expressions that I'm going to work with. So if I set each of these equal to 0 and solve, these are going to be my three answers: 7 pi over 6, 11 pi over 6, and pi over 2. Alright, so go ahead and pause the video and try this example next. The answer is here. Alright. This time you have 3 different trig functions. This is bad. So let's start by changing everything to sines and cosines. So let's take that tangent and replace it with sine over cosine. Once I do that, you'll notice that I can multiply the sine by sine to get sine squared, and then this sine is really over 1, so it becomes cosine. In order to be able to add these two, I'm going to get a common denominator. So that same technique that we used for identities and verifying, we can use here as well. So if I multiply both top and bottom by cosine, I get cosine squared over cosine. I'm going to go ahead and add those numerators now. And then cosine squared plus sine squared becomes 1. So I now have 1 over cosine of x. If I multiply both sides by cosine and divide both sides by 2, you end up with cosine of x equals 1/2. So now to solve this, you'll get 5 pi over 3 and pi over 3 as your two answers. For example 9, we'll do something very similar. You've got a cosecant and a cotangent. They're not the same on both sides, or they're not the same trig function either. So I'm going to start by at least changing them both to sines and cosines. So cosecant becomes 1 over sine. Cotan becomes cosine over sine. And then I'm going to, since they have the same denominator, put those two together. And so I get 1 plus cosine over sine equals 1. I'll multiply both sides by sine, and I end up with cosine of x plus 1 equals sine of x. Now this is a little bit of a tricky problem here because there's really not anything else you can do as far as any of your techniques or anything like that. So what I'm going to do is going to be a new technique. I'm actually going to square both sides. So when I square both sides, I'm going to FOIL the left-hand side. And so now I end up with this when I FOIL and sine squared on the right. When I look at this, I have two trig functions. One is cosine, one is sine. Again, this is bad, so we want to replace this sine with 1 minus cosine squared. We'll put everything on the same side together. And then once I do that, I have a GCF of 2 times cosine that I'm going to go ahead and factor out. That becomes 2 cosine x times cosine x plus 1. And I'll solve each of these individually. I'll get cosine of x equals 0 and cosine of x equals negative 1. When I solve the first one, I'll get pi over 2 and 3 pi over 2. And when I solve the second one, I'll get pi. Now, another reason this problem is tricky is because you squared both sides. You actually could possibly pick up extraneous solutions. This is the only method that you would possibly get that with, so we do need to check these answers to make sure that all of them work. If you plug 3 pi over 2 back into the original, you end up with cotan of 3 pi over 2, which is cosine over sine. That is okay, so cosine of 3 pi over 2 is 0 over sine, which is negative 1. That one's actually okay. so you end up with 0. And then cosecant becomes 1 over sine. The sine of 3 pi over 2 is -1, so you get -1 plus 0, which is -1. That is not a true statement because -1 is not equal to +1. So 3 pi over 2 will not work. If you try both pi over 2 and pi, they will both work. All right, we'll go ahead and stop here. This is a calculator problem, so I'll explain how to do that in class. And that should be the end of, yes, that's going to be the end. All right.